Hello everyone, I am Aswani, Assistant Professor, Department of AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In this today's session, we are going to learn about convolutional neural networks. What is convolutional neural networks? What are the layers are there in the convolutional neural networks? So we'll see in this session. Let's see the overview of this session. Introduction about CNN, example, and various layers of CNN, applications of CNN. Let's see the introduction part. So, if you want to recognize any image as a human being, then we can easily recognize that. For example, there is a cat or there is a crow, like that. Like a kids, if they don't know what is that crow or sparrow, we will teach them. It is a crow, it is a sparrow, based upon the color, based upon the looking, we'll teach the kids. In the same way, here also, if you give any input as an image to that computer don't know what it is. So first we need to teach the computer what that image contains, what it is. So to do that, we are having convolutional neural networks. This convolutional neural network is a type of special types of neural networks designed to process and analyze grid-like data structures or commonly images. So which use it to primarily for image recognition and processing due to its ability to recognize patterns in image. So the CNN is used to recognize the image, detect the image, and also recognize the patterns. Based upon that patterns, it will be able to come to one of the decision that says that, okay, it is a cat or it is a crow or it is a sparrow. So first we need to teach. To teach that, we need to have convolutional neural networks. Let's see the example. So first, the input image is a cat. So before giving this image, before modeling, before teaching this is a cat, the computer don't know what image it is. So first we need to give that image, teach that image. Later on, whenever we give that same similar kind of images, then it is easily identify, okay, this image is a cat. Like that, it will classify the images. Okay, so here first we'll give image as the input, and later it will perform the convolution layer. In this convolution layer, after that a pooling layer, after that a dense layer or fully connected layer, and finally output layer. First, we'll give the image within the numerical values. It will pass to the convolution layer. In that convolution layer, there is a filter or kernel will be there. Using that kernel, it will be passed over to the images, and it is used to identify the shapes, patterns, and edges of that image, and that important feature map will be passed to the pooling layer, and again pooling layer will do the down sampling, means whatever important will be there, it will take those pooling layers, then it will pass to the dense layer or fully connected layer. In this dense layer, it have each neuron is connected with the other neuron, means whatever is there that will be fully connected, and finally it will be classified, means in the output layer it is a judgment layer, we can say. So it will be says that, okay, it is categorized as a image, categorized as a cat or crow or sparrow. Like that, it will be classified the image. Okay, next let's see the various layers of the convolutional neural network. The first layer is input layer. In the image we have already seen input layer, convolution layer, pooling layer, dense layer, and output layer. Let's see the input layer. So what is the input layer? Input layer is an image. It will pass that image in the form of pixels, large values of pixels. Okay, let's see. The input layer represents the raw pixel values of the image. In this example, the input is an image of cat. In the previous slide, we have seen that this is a cat image we are supposed giving to the image, to the convolutional layer. Okay, so what is the functionality? This layer does not perform any computations. So just it will take that image and it will convert that image into the large number of pixels and it will serve to the convolutional layer and it will say as a entry pointer. Okay, okay. So here this layer does not perform any computation but serves as the entry point for the image data into the CNN. The next layer is convolutional layer. This layer is the important layer and it will perform the flatten. So let's see the description about convolutional layer. The convolutional layer applies several filters or kernel filters to the input image to produce a set of feature maps. So basically the convolution layer is used to identify the patterns, shapes and edges etc. of the image. Okay, so what is the functionality? Here each filter slides over the image, input image, and it will sum up all the values and it will produce the new value so that it will be shrink. Means whatever important features are there, those will be produced as an output. Let's see. Each filter slides over the input image, performing element-wise multiplication and summing the result to detect specific features such as edges, textures and patterns. These filters help in capturing spatial hierarchies in the data. So there is a filter will be taken to train the model to teach the image as a cat to the CNN, to the computer. Then we need a filter. So for example, take this as the filter. When we are trying based upon the scenario, based upon the image, this filter will changes. Okay, this filter is slides over the input image. Whatever input image is there, it will be multiplied and sum up all the values and it will be produce the output. Let's see the first one. This 3x3 matrix. Basically, this filter is in the form of matrix, either 3x3 or 5x5 or 7x7 based upon the complexity of the image. Okay, so here this is the image pixel values. So first these values, how it will produce? Let's see. 1 will be multiplied with 0. This one. It will consider first 3 rows and 3 columns. Okay, 1 into 0. Next 0 into 0 and minus 1 into 1 plus the 3 rows and 3 columns multiplied with each and every value and sum up the values. Plus again 2 into 0 plus 0 into 0 and minus 2 into 1. 2 into 0, 0 into 1, sorry. Next again 1 into 1. Again here plus 0 into 1. Minus 1 into 1. Okay. After summing multiplication and sum up all these values, we'll get the value as minus 3. This is the output. Look at these values. Okay. Next again, after completing this region, it will goes to the next line. So next it will consider, it will leave the first column and it will goes to the next 3 columns and again it will perform, then the output is 0. Next again it will goes to the next line, it leave the next line and it will goes to the next. Okay, next the output is 3. Whenever it will reaches to the next, here only 2 columns are left, so it won't perform anything, then it will comes to the next one. So it will leave the first row, then it will comes to the next one, next 3 by 3 matrix. The value is minus 2. Again it will leave the first line and it will goes to the next 3. Next 0. Again the process is continue until the last one. So 2 is the value. Next again it will leave to the first 2 rows. Next it will comes to the first region. Next again second region. Okay, after that again third region. The values are minus 3, 0, 3. Okay, this is the output of the convolutional layer. So this output is the input to the pooling layer. This will be passed to the pooling layer. So here the functionality of convolutional layer is the each filter slides over the input image. Starting from the first row, it will reach across to the last one, and it will identify the shapes. It will identify the shapes and also be edges and also pattern or color. It will gives that feature map as a output. Next, whatever the output is produced in convolutional layer, that will be passed to the pooling layer as an input. So what pooling layer will do? The pooling layer will perform the down sampling, and again whatever feature map is taken from the convolutional layer, it will take that one, and again it will search for what are the important things. If you see some scenarios, if you, for example, if you are planning to go some traveling, some trip, then we will pack the in everything before 2 days only. But what happens on the day, we will forget something, and again that is also very important, and we will pick that one. In the same way, here also pooling layer will perform down sampling, and it will give as an output important things of that image. Okay, let's see description about a pooling layer. After the convolution layer, a pooling layer is applied to reduce spatial dimensions of the feature map. Already after convolution layer, the image, whatever image, actual image is there, that is reduced by applying the filter over the image. And again this whatever 3x3 is there, that is passing to the pooling layer. Again from that, it will again take the only important things, and it reduces the spatial, means again it will shrink that image. Okay, let's see the function. The pooling operation down samples the feature maps by taking the maximum value. Here in the pooling layer, there are 3 types of poolings. One is max pooling, average pooling, and global pooling. Maximum in the pooling layer, it will apply the max pooling only. Whatever the in the 2x2 or 3x3, whatever max value is there in that region, it will take only that value as a output. Okay, let's look at the functionality. The pooling operation down samples the feature maps by taking the maximum value from each region of the feature map. In that feature map, it will take one of the maximum value. For example, consider this one 0001. For example, it is a 2x2. Then it will take 1 as the maximum value. In such a way, it will take split the regions, and it will take the maximum values. Okay, this reduces the size of the feature map, making the computation more efficient and providing some translation invariance. If you give the large amount of data to the computer, it will be some quite slow to learn that entire feature map. That's why when we shrink that feature map, we are giving less training data, then it is efficient to learn, and it will apply whatever learn the things. So that's why the pooling layer is used to perform down sampling, or it will, we can say, reduce the spatial dimensions of the feature map. The next layer is dense layer, or we can say a fully connected layer also. Let's see the description. The dense layer, also known as fully connected layer, comes after several convolutional and pooling layers. We won't apply only one or two processes only one time or 2 times. It will be performed multiple times. Whatever we have seen here, filter slides over the image, it is not done only one time, because here we have taken only simple image. But whenever it is comes to the real time example, it will goes to the 28x28, 64x64 image pixels. So for that images, will perform multiple times the same procedure. That's why here, after performing multiple times, it will comes to the dense layer. Let's see what is the functionality. The dense layer takes the flattened output from the pooling layers and performs high level reasoning each neuron in this layer is connected to every neuron. So in the image, in the example, we have seen cat. First it will connect with the each and every neuron with the other neuron, means the shape is like a ear or eyes or nose. It will connect, and later that pattern will be learned the computer. Okay, each neuron in this layer is connected to every neuron in the previous layer, allowing the network to combine features to make predictions. So after combining all the neurons, it will learn, okay, it is a ear, it is a nose, it is a eyes. Like that it will learn, it will comes to the predictions. Next, last layer is output layer. This output layer, we can simply say that it is a judgment layer. So it will classify whether the image is a cat, or image is a crow, or image is a star. Like that it will classify the images. Let's see the description. The final layer in the network, responsible for producing the classification result. So two types of classifications, a binary or multi classification. In the binary classification, it uses the sigmoid activation function. Based upon the activation function, it will comes to the one of the decision. Next, if it is a multi-class classification, then it uses the softmax activation function. Let's see the functionality overall. The output layer uses an activation function. If it is a multi-class classification, softmax is the activation function. If it is a binary classification, then sigmoid I is the activation function to produce a probability score for each class. So in this example, the network outputs the probability of the input image being a cat. After connecting all the neurons, then it will comes to one of the result says that it is a cat. Okay, and then next we'll see what are the applications of CNN. So the first one, image classification. In this, here CNN is used for classification mainly using the images. In the traditional neural networks also do the same, but they are identifying, and if you give the large amount of pixels, then the performance a little bit slow. That's why here CNN will be used. The first one is image classification. So it recognizes the objects within the images, and it will be classified. Okay, it is a cat, or it is a crow, or it is a sparrow. So where it will be used in the social media, we can use our photo apps, we can use means identifying. If you see the Android mobiles, there is a feature says that, okay, for example, A's photos, B's photos. Whenever we will take the picture, then it will segregate, okay, this person is A's, then it will go send to the A's folder. Then whenever we take the picture to the B, then it will goes to the B's. So identify, and it will classify the images according to the persons. That is image classification. Next, object detection. So not only classifying images, it will detect the object also surrounding. So for example, in traffic signals, it will draw the surrounding images also. Locating objects within an image and classifying them. Example, detecting cars in a street scene, like that. Next one is image segmentation. So classifying each pixel in the image to separate different objects, segmenting different organs in a medical image. For example, MRI scan. Then it will separate all the organs in the different way. So that is the image segmentation. Next one is face recognition. So if you want to unlock the mobile, then face will be recognized. Or if you want to give the attendance in your offices or institutions, then we will use the face recognition as a security. So identifying or verifying individuals based on their facial features. Next one is medical imaging. Analyzing medical scans like MRI, CT scans, whether tumor is present or not, to identify the diseases or abnormalities. Also, we will use the CNN. Next, autonomous vehicles. So, enabling self-driving cars to understand their surroundings through camera feeds. So, pedestrian, like that, the cameras will capture the objects surrounding that cars, and it will take the another route, like that. Autonomous vehicles. In this also we'll use the CNN. These all are the applications of CNN. So In this session, we have seen introduction, what is CNN, why we use CNN, and we have seen one example how it will be produced, learn the image. Okay, next various layers, input layer, convolutional layer, output layer, dense layer, and pooling layer. We have seen the multiple layers. Next, applications. What are the different applications of the CNN? Like